On a certain workday, the rate at which unprocessed gravel enters the processing plant is modeled by g of t. T is in hours. At the beginning of the day, there's 500 tons. During the hours of operation, t is between 0 and 8. The plant processes gravel at a rate of 100 tons per hour. Part A, find g prime of 5. Okay, well, we have g of t. You can just take the derivative and evaluate it at 5, right? So this is going to be done in your calculator, because this is a calculator question. So you can literally just take this function and ask your calculator to take the derivative of it at t equals 5. So if you do that in your calculator, right, you do g prime of 5, you will get negative 24.588. Okay? And then we want to figure out what does this mean in the context of the problem, okay? And first let's figure out the units for g prime of 5. Right, so g prime of 5, what this really is the derivative of g, or sorry, it's the derivative of g with respect to time at t equals 5, right? That's what this is. Well, we know that the units for g is tons per hour, right? So it's tons per hour, and the units for t are hours. So the units for the derivative are tons per hour, tons per hour, or tons per hour squared, right? So what this means, we know that g of t tells us the rate at which the gravel is arriving, so g prime of t should tell us how much that rate is changing. Specifically, g prime of 5 tells us how quickly the rate is changing at t equals 5. So this means that at t equals 5, the rate of gravel arrival is decreasing by 25.588 tons per hour. Or you can say that the rate of gravel arrival is changing by negative 24.588 tons per hour. Okay? This was a 2-point question, 1 point for the numerical answer, and 1 point for the explanation with the correct units. Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Alright, so workday, that's defined as, t is between 0 and 8, right? 8-hour workday. So we want to figure out total amount of unprocessed gravel. So g of t doesn't tell us the amount of gravel, it tells us the rate at which gravel is arriving, right? So what we want to do is we want to add up all of those little bits from 0 to 8, right? That'll tell us how much gravel arrived at the plant throughout the entire time interval. Okay, so the way we add up all those little bits, that's going to be through integration, right? So we're going to integrate g of t from 0 to 8. Whenever you have like the rate function and you integrate it across the time interval, you'll get the total amount across that interval. Okay, so g of t, that's going to be 90 plus 45 cosine t squared over 18, yada yada, dt. Okay, cool. So you take this, put it in your calculator, you're going to get 825.511 tons. Okay, and tons, that's pretty obvious, right? Because they're asking us for the amount of gravel, and gravel is going to be measured in tons, right? Since the rate is in tons per hour, the amount of gravel is going to be tons. Sometimes you want to rely on your common sense over like getting bogged down in the math, right? Okay, so this was a 2-point question, 1 point for the integral, 1 point for the answer. Is the amount of unprocessed gravel in the plant increasing or decreasing in t equals 5? Show the work. Okay, so is the amount of gravel increasing or decreasing? Let's see, so we need to think about this logically, right? So to figure out the amount of gravel in the plant, we need to think about, so here's like a plant, right? So there's some gravel coming in, and there's some gravel going out. If the amount that's coming in is more than the amount that's going out, then the amount of gravel is increasing. But if the amount that's going out is more than the amount that's coming in, then the amount of gravel is decreasing, right? So we have to think about at t equals 5, which is greater, the amount that's coming in or the amount that's coming out. That'll tell us if the amount of gravel is increasing or decreasing. Okay, well, one of these is really easy. The plant processes gravel at a constant rate of 100 tons per hour. So the amount that's coming out is 100 tons per hour all we need to do now is figure out the amount of gravel that's coming in. How much gravel is coming in? Well, we know that's going to be given by g of t, right? That's the rate at which the gravel is arriving. So at t equals 5, we need to find g of 5. Okay? If we evaluate g of 5 in our calculator, that's going to be 98.14. Okay? Approximately 98.14. So the rate at which gravel is coming in, you can see, it's coming in at 98.14 tons per hour. Okay? So it's coming in at 98.14 tons per hour, and it's going out at 100 tons per hour. So clearly, the amount that's going out is more than the amount that's going in. So the amount of gravel must be decreasing, right? Because there's more leaving than there's coming in. So for your explanation, you'd say something like, the amount of gravel that's going out is more than the amount of gravel that's going in, right? Because 100 is greater than 98.14. So at t equals 5, the amount of unprocessed gravel is decreasing. This was a 2-point question, 1 point for the answer, and 1 point for making a comparison between the amount of gravel that's going out, which is 100, and the amount of gravel that's coming in, which is 95 or 98.14, which is g of 5. Okay, so those are the 2 points, and let's keep on. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. Okay, so let's think about how much unprocessed gravel there is at a certain time. Okay, so we know we're starting off with 500 tons. We know we're starting off with 500 tons of unprocessed gravel, right? So we're starting off with 500, and then we have some coming in, and we have some going out, right? But this tells us the rate. And remember what I told you earlier, to find the actual amount of gravel from the rate, you have to integrate it, right? You have to integrate the rate function to get like the actual amount. So we're integrating, and what are we integrating? Well, we know this gravel is coming in, so g of t is coming in, and this gravel is going out. So we're actually going to subtract it because it's taking away from the amount of gravel. Okay? So we're integrating dt. This is going to tell us how much gravel there is, how much gravel, like the net change basically from when you started. You started this, and so from 0 to t, so you're starting at t equals 0, and you're going t equals whatever. This will tell you how much the amount of gravel changed, right? So some came in, some went out, totally changed by whatever this is, and then you also have the initial 500, right? This function here is going to give us the amount of unprocessed gravel at some time, okay? And so we want to find the maximum amount of unprocessed gravel. So we want to maximize this, right? We want to maximize this function. So remember how to maximize stuff. You take the derivative, set it equal to 0, right? So we can take the derivative of all that. That's going to be, so the derivative of 500 is 0, and then the derivative of the integral. Remember, the derivative of the integral, the derivative and the integral sort of cancel out, and we're just left with g of t minus 100. Okay? And we want to set this equal to 0, so on a new line, I'll set g of t equals to 100, or no, I'll say, here, I'll explain, I'll do one more step in between. G of t minus 100 equals 0, so g of t equals 100. Alright, so if we solve this for t, you get t equals 4.92. The way I'd recommend doing that is graphing g of t in your calculator, and then graphing 100, and then finding the intersection point. Okay, so now to figure out the absolute maximum, we have to test this critical point in addition to the endpoints. So we're going to set up a little table. We have t, we have g of t, and we're going to put, for t, we're going to put the endpoints, which is 0 and 8. Remember, the work days from 0 to 8, right? So 0 and 8. And I'm also going to put this critical point, 4.92. Right? Now we're going to find g of t, or not g of t. Sorry, that's my mistake. We're going to find the amount of gravel at each of these three t values that's going to tell us, and whichever of these is the most, that's going to be when the amount of gravel is the most. Okay? So at time t equals 0, there's 500 tons of gravel, right? That's given to us in the problem. And then at t equals 4.92, how do we figure that out? Well, we literally just take this function. Remember, we said this function tells us the amount of gravel, right? We're going to take this function and plug in t equals 4.92 into here. So you do 500 plus the integral from 0 to 4.92 of g of t minus 100, and you put that in your calculator, and you're going to get 635.38. Okay? If you do the same thing with t equals 8, you're going to get 525.55. Okay? So, as you can see, the maximum of these three is this one. So we know that the maximum amount of gravel in the factory is at t equals 4.92, and that maximum amount is 635.38 tons of gravel. Okay, this was a 3-point question. 1 point for taking the derivative and setting it equal to 0, 1 point for the correct answer of 635.38 tons, and another point for the justification. This is our justification for this problem. Okay, and with that, we're done with question 1. A particle is moving along in a straight line. For t between 0 and 5, the velocity is given by that, and the position is given by s of t. It is known that s of 0 equals 10. Part A, find all values of t in the interval from 2 to 4 for which the speed of the particle is 2. Okay, so this is basically a speed versus velocity thing, right? So a lot of people think speed and velocity are the same. They're not. There's one minute difference, right? So basically, speed is the absolute value of velocity. Okay, that's pretty much it. So speed doesn't take into account direction, but velocity does. Okay, so if we want to figure out when this speed is equal to 2, we'll take the absolute value of the velocity. So the absolute value of -2 plus this whole mess. Okay, we'll set that equal to 2, and this is going to be done in your calculator, right? You graph this, you set it equal, you set it equal to 2, and you get t equals to 3.128 and 3.473. Again, the best way is to graph this. You should look up how to do the absolute values in your calculator if you're not sure, but you graph this in y1, graph this in y2, set them equal to each other, find the intersection point, and you get 2 of them right there, okay? So this is a 2-point question. 1 point for setting the velocity, the absolute value of the velocity equal to 2, and another point for the right answers. This is where the speed is equal to 2. Okay. Write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at t equals 5. Okay, so we know that the integral of the velocity gives us the position, right? So the integral from a to b of the velocity gives us the change in position, gives us the position at b minus the position at a, right? So if we want to figure out the position, we'd say, all right, if we integrate velocity from 0 to some time t, we get the position at that time t minus the position of 0. What's the position of 0? S of 0 equals 10. So I can replace s of 0 with 10, and then I'll solve this for s of t to give me 10 plus that integral. Okay, and this is that s of t function that will give us the position. Now, we need to find the position of the particle at t equals 5, okay? So s of 5 is going to be 10 plus the integral from 0 to 5 of the velocity. Okay? So if you put this in your calculator, you're going to get negative 9.207. Okay? This was a 2-point question, 1 point for the correct expression, and 1 point for the correct answer for s of 5. Part C, find all times t in the interval from 0 to 5 where the particle changes direction. Justify your answer. Okay, so when the particle changes direction, we're looking at when the velocity switches sign, right? because when the particle is moving to the right, it has a positive velocity, or at least that's convention. And when the particle is moving to the left, it has a negative velocity. So when it changes direction, its velocity switches from positive to negative, or from negative to positive. Okay? And the way we figure what those points are, the way we figure out where those points are, is we set the velocity equal to 0, and then look at what's going on around those points. So to figure out where it changed direction, we have to look at where the velocity is equal to 0. Okay? So I want to take my velocity, set it equal to 0. Okay? If you do this in your calculator, again, you're going to graph this, and this time you can just check for the zeros of the function, and you'll get 2 of them. You'll get t equals 0.536 and t equals 3.318. Okay, and now what we got to do is we got to check. All right, are these actually points where the particle is changing direction? Okay, and the way we do that, or the way I do it at least, is I use a number line. Okay, so what you're going to do is you're going to put your two t values, so 0.536 and 3.318, right? And I'm going to check the signs in between these two places. So this is for velocity, right? I'm going to check the sign of velocity using some number that's greater than 3.318. So I'll use, like, for example, 4. If I plug in 4 into my velocity, I'll get a negative answer, okay? So in this section, it's negative. If I plug in a number in between 0.536 and 3.31, say, for example, I plug in, like, 1, then I'm going to get a positive answer, okay? And then if I plug in a number that's less than a 0.536, I'll get a negative answer. Okay, so as you can see, at 536, the velocity switches from negative to positive, and at 3.318, it switches from positive to negative. So, therefore, we know that all the times t where the particle changes direction. Oh, I forgot to mention, it's important to mention. The numbers that you plug in to t have to be between 0 and 5. So you can plug in, like, negative 10. I don't know if that'll work, but you want to make sure it's in the interval, okay? So where was I? Yes, okay, so we can see that the particle switches direction at both of these instants because the velocity switches sign. So the particle changes direction at t equals 0.536 and t equals 3.318. This was a 3-point question, 1 point for setting the velocity equal to 0, and 2 points for the correct answer along with the justification. This can serve as a justification of sorts as well. Is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. Okay, so to look at this, if the speed is increasing or decreasing, you always need to look at both the velocity and the acceleration. Okay, so at time t equals 4, we need to find v of 4 and a of 4. Okay, a is the acceleration, v is the velocity. So v of 4 is easy. You just plug in you plug in 4 into this function in your calculator, and you're going to get negative 11.476. Okay, and to figure out the acceleration, you have to know that acceleration is the derivative of velocity. So a of 4 is equal to v prime of 4, right? So if you take this function and you figure out the value of the derivative at t equals 4, again, that's going to be done in your calculator, right? You can ask your calculator to find the derivative of this at t equals 4. If you do that, you'll get negative 22.296, okay? Now it's important to check the signs. That's going to tell us this, if the speed is increasing or decreasing. So you can see these are both negative, right? So since they both have the same sign, we know that this particle speed is increasing, okay? So you'd say the speed is increasing because v of 4 and a of 4 have the same sign. That's our reason for the answer, okay? And this was a 2-point question, 2 points for the correct answer with the explanation. That's question 2. Hot water is dripping through a coffee maker. The amount of coffee in the cup is given by the differentiable function c, where c is t is measured in minutes. Selected values of c or t are given in the table, well, in this case is below. Part A, use the data in the table to approximate c prime of 3.5. Okay, so we don't know a function c that we can actually take the derivative of and plug in t equals 3.5. So what we have to do is we have to find 2 points that are around t equals 3.5. In this case, those 2 points are going to be 3 and 4. and we need to find the slope between those 2 points. And that's going to be an approximation for the slope at the exact 1.3.5. Okay, so instead of exactly looking at the slope at 3.5, we'll be taking the slope between 3 and between 3 and 4. Okay, so it's going to be C of 4 minus C of 3, C of 3 over 4 minus 3. That's 12.8 minus 11.2 over 1, which is 1.6, and units of measure. So we know that the units for C are ounces, right? And the units for T are minutes. So we're dividing ounces by minutes. So the units for the derivative are going to be ounces per minute. It's a bit vertical there, but there we go, 1.6 ounces per minute. This was a 2-point question, 1 point for the answer, 1 point for the units. Part B, is there a time t where 2 is less than or equal to t is less than or equal to 4, at which c prime of t equals 2? So this is talking about the mean value theorem, and to make sure that the mean value theorem even applies, we have to make sure if our function even fits the conditions. So we're given that c is a differentiable function, right? So it's a continuous function. So we know that the mean value theorem is going to apply in this case, right? There's no like sharp points or whatever, so that would make it not differentiable. Okay, so we know that the mean value theorem is going to apply, so we need to find the average rate of change between 2 and 4. Okay, so the average rate of change is going to be C of 4 minus C of 2 over 4 minus 2. It's going to be 12.8 minus 8.8, 12.8 minus 8.8 over 4 minus 2 is 2. This is going to be 6.4 minus 4.4, which is 2. So we know the average rate of change is 2. And by the mean value theorem, since the conditions are met for the function, we know that there is some time t in between 2 and 4 where the derivative is equal to the average rate of change. So there's some time where the derivative is equal to 2. Okay, so by the mean value theorem, there is at least one time t where t is between 2 and 4 inclusive, where c prime of t is equal to 2. This was a 2-point question, 1 point for calculating the average rate of change, and 1 point for the answer with an explanation. Use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1 over 6 times the integral from 0 to 6 of c of t dt. Using correct units, explain what it means in the context of the problem. Okay, so whenever you see a fraction times an integral, right, and the difference between the numbers in the integral is the denominator of the fraction, in this case 6 minus 0 is 6, and 6 is in the denominator, you immediately know that this thing is giving you the average value of that function in the integral. So this is giving you the average value of c of t. So we already know what we're going to say for the second part, but let's first calculate the actual value of that this expression. Okay, so 1/6 times the definite integral from 0 to 6 of c of t dt. Okay, so we're talking about 3 subintervals of equal length in the table, right? So we have from 0 to 6. So the 3 subintervals are going to go from 0 to 2, 2 to 4, and 4 to 6. Okay, those are the 3 equal subintervals, right? And since this is a midpoint sum, what we're going to do is, so for this first subinterval, from 0 to 2, okay, we're going to subtract the 2 t values, okay? So 2 minus 0 is 2, and then we're going to multiply that by the c of t value that's in the middle. So from 0 to 2, right, the one in the middle is 5.3. That's why it's a midpoint sum. You're multiplying by the thing in the middle. Plus, and then so from 2 to 4, we're going to subtract 4 minus 2 is 2, and we're going to multiply that by the thing in the middle, 11.2. Plus, and then from 4 to 6, we're going to subtract the t values. So 6 minus 4 is 2 times, and then we're going to take the c of t value that's in the middle, so 13.8. Okay, and if you evaluate this guy in your calculator, this whole thing, don't forget the 1/6, you're going to get 10.1 ounces. Okay, that's 10.1 ounces. Okay, what does that mean? Well, like I said, this integral is equal to the average value of C of t. And C of t is the, what is it? C of t is the amount of coffee in the cup. So this must be the average value of the coffee in the cup, the average amount of coffee in the cup between t equals 0 and t equals 6. Okay? So this 1/6 integral from 0 to 6 C of t is the average amount of coffee in the cup over the interval from t equals 0 to t equals 6. Okay? That was question 3, part C. This was a 3-point question, 1 point for the sum, 1 point for the answer, and 1 point for the explanation of what it means. The amount of coffee in the cup in ounces is modeled by B of t is equal to 16 minus 16 e to the negative 0.4 t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. Okay, so B of t is telling us the amount of coffee in the cup, but we don't want to find the amount of coffee in the cup. We want to find the rate at which the amount of coffee in the cup is changing. Okay, so B of t is telling us the amount of coffee in the cup, and to find the rate at which the amount of coffee in the cup is changing, we need to take the derivative of B to find B prime of t. Okay, so let's find B prime of t. Alright, so the derivative of 16 is 0. And then remember, the derivative of e to the x, the derivative of e to the x is e to the x, and the derivative of e to the bx, where b is a constant, is b e to the bx. Okay, so the derivative of negative 16 e to the negative 0.4 t is going to be negative 16 times negative 0.4 e to the negative 0.4 t. Okay? What this is 16 times, negative 16 times negative 0.4. The negatives will cancel out, so we'll get a positive 6.4 e to the negative 0.4 t. Okay? And we want to find out b prime of 5. Well, it's going to be 6.4 e to the negative 0.4 times 5. Okay, you don't really have to simplify further than that. That's plenty simplified. Okay, this was 2 points. 1 point for figuring out b prime of t, and 1 point for figuring out b prime of 5. That concludes question number 3. The figure above shows the graph of f prime, the derivative of a twice differentiable function f from 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, 3, and 5. 1, 3, 5. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. Find all values of x on the open interval from 0 to 8 for which the function has a local minimum. Justify your answer. Okay, so it's important to realize here that they're asking for where f has a local minimum, not f prime, right? So if we were to draw a graph with a local minimum, right, it looks something like this. The minimum would be right here, right? That's where it's like the bottom of this graph. And then notice when we're looking at the derivative, and this part to the left, it's negative, right? It's sloping down. And then to the right, it's positive, sloping up. So at the local minimum, the derivative switches from negative to positive. So in our graph of the derivative, we have to look at where it switches from negative, so under the x-axis, to positive, so over the x-axis. And we see, looking at the graph, that the only point where f prime of x, which is from below to over the x-axis, is right here. So it's x equals 1, 2, 3, 4, 5, 6. This is x equals 6. Okay, so, and they want us to justify our answer, so we'd say x equals 6 is where there's an absolute minimum, because that's where f prime of x, which is from negative to positive, so which is at x equals 6. Okay, so there's a local minimum there. Part B. Determine the absolute minimum value of f on the closed interval from 0 to 8. Justify your answer. Okay, so we're looking for the absolute minimum. That can come in one of two places. It can either be an endpoint, or it can be a relative minimum. Okay, so we're going to check all of the endpoints and all of the relative minimum to find out where the absolute minimum is. Okay, so what we're going to do is we're going to set up like a little table, right? So we'll have x and f of x, and in the x we'll put all of the endpoints and all of the relative minimum. Okay, so the endpoints, so we're going from 0 to 8, so the endpoints are 0 and 8, and then we also have a relative minimum, remember, at x equals 6, right? And so we need to figure out what is f of 0, f of 6, and f of 8. Well, we know f of 8, that's equal to 4, right? But how do we figure out f of 6 and f of 0? Okay, well, what we're going to do is we're going to set up an integral, okay? So we'll start with f of 0. So f of 0. So we know that if we integrate from 0 to 8, and the reason I'm choosing 0 and 8 as my endpoint is because we know f of 8, and we want f of 0. Integrating from 0 to 8 of f prime of x dx, this is equal to f of 8 minus f of 0, right? And we want f of 0, so we can say, oh, f of 0 is f of 8 minus this whole integral business. Okay, and so we know f of 8, right? We said f of 8 is 4. And what is this integral? The integral from 0 to 8 of f prime of x dx. Well, remember, all that an integral is just the area under the curve. So we have f prime here. I can just figure out the area under the curve from 0 to 8. So this is plus 2, this is plus 6, so totally it's plus 8. And this is minus 3 because it's under the x-axis. So plus 8 minus 3 is plus 5. And then we have another plus 7 because it's above the x-axis. So we have plus 2, plus 6 is plus 8, plus 5, and then plus 7 is plus 12 in total. Okay, so this is going to be 12, and this is going to be 4, right? Because again, f of 8 is 4. So the final value is f of 0 equals 4 minus 12, which is negative 8. And that's what's going to go here. Okay, it's a really similar thing for finding f of 6, but we'll have the integral this time going from 6 to 8 instead of from 0 to 8. Okay, so f of 8 minus f of 6, that's 6. F of 6 equals f of 8 minus that integral. Okay, what is the integral from 6 to 8? Well, let's see here. Oops. There you go. What is the integral? Well, let's see. We're going from 6 to 8. You can see that area there is 7, right? So, again, this is 4, and this is 7. So, f of 6 equals 4 minus 7. Again, that is 6, which is negative 3. So the area here is negative 3. Okay, so now we're to figure out, alright, which of these is the lowest. Because remember, the absolute minimum is the lowest value. And as you can see here, the lowest of these 3 is negative 8. So you'd say, alright, the absolute minimum of f from 0 to 8 is negative 8. Right? Because they asked you for the absolute minimum value, so the value is negative 8. It occurs at x equals 0, but they want the actual value, which is negative 8. And then our justification would be this table, because we're showing all the possible points, and we're testing them out one by one. Okay? This was a 2-point question, 1 point for the answer, and 1 point for justification. On what open intervals contained in 0 to 8 is the graph of f both concave down and increasing? Explain your reasoning. Okay, so we'll take this part by part. So first we're looking at concave down, right? So what does it mean if f is concave down? And since all the information we have is about f prime, we're going to relate all of these things to f prime. So if f is concave down, what does that tell us about f prime? If f is increasing, what does it tell us about f prime? And then we'll look at f prime, and then we'll make our final answer. Okay, so that's our strategy here. So we'll start. Okay, so if f is concave down, what does that tell us about f prime? Okay, well, I know that if f is concave down, that means that f double prime is negative. That's what it means to be concave down. The second derivative is negative. And then if I know that the second derivative is negative, I know that the first derivative is decreasing. Okay, so if f is concave down, then f prime of x is decreasing. Okay, and then we also know f is increasing. Okay, well, if f is increasing, that means f prime of x is positive, right? It has a positive slope, it's increasing. Okay, so we know that f prime is decreasing and it's positive. So if you look at all the areas here where f prime of x is both positive and decreasing, so it's going down, but it's still above the x-axis. And I can see there's one region here, right, from 0 to 1, where it's going down and it's positive. And there's this other region here, where it's going down and it's positive. So those are the only two regions here that fit that criteria. So we can say that from 0 is less than x is less than 1, and 3 is less than x is less than 4, right? Because it's 1, 2, 3, 4. So this region and this region, those two regions, because those are the regions where f double prime of x is decreasing, or sorry, where f prime of x is decreasing and positive. But these are the two regions that fit that criteria. And this was a 2-point question, 1 point for the answer, 1 point for the explanation. Alright, the function g is defined by g of x is equal to f of x cubed. If f of 3 is equal to negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. Okay, so if we want to find the tangent line, we need the point and the slope, right? But we just want the slope of the tangent line. If you remember, when we wrote down, point slope for all the other FRQs, we'd say, oh, this is 3 comma g of 3 and g prime of 3, right? But no, they don't really care about this part. We're just focusing on the slope, g prime of 3. So basically, they're asking us for g prime of 3, okay? So we have g of x. So we need to take the derivative of that to find g prime of x, right? So first, we'll just deal with this outside function, the cube part. And we'll say, okay, 3 f of x squared, right? We're treating f of x like one singular thing, and we're just using the power rule on it. And then, since f of x is another function, since this is a function inside a function, we need to use the chain rule and multiply by the derivative of f of x, which is f prime of x. Okay, so now we need to find g prime of 3. It's going to be 3 times f of 3 squared times f prime of 3. Okay, what's f of 3? Well, f of 3 is negative 5 halves. So just 3 times negative 5 halves squared times f prime of 3. What's f prime of 3? Well, if we go here, 1, 2, 3 for x, f prime of 3 is 4, right? Because of the graph of f prime. So f prime of 3 is 4. So this is g prime of 3. You don't really have to simplify that. That's good enough. This is the value of g prime of 3. This is a 3-point question. 1 point for successfully taking the derivative of g of x, and 1 point for the correct numerical answer. That's question 4. Let f of x equals 2x squared minus 6x plus 4, and g of x equals 4 cosine 1/4 pi x. Let R be the region bounded by the graphs of f and g as shown in the figure above. First thing I want to do is label f and g, right? Because even though it's kind of obvious, it's not super duper obvious, so just to be safe, let's make sure we don't mess anything up, right? So the polynomial is the one that's going like this, right? This is f of x, the bottom. And g of x, remember, is the one that's cyclic, right? It goes down and up and down and up. And this is the cosine graph. It's starting to go down, right? Because it starts at the high point and then it goes down. So this is g of x as a cosine. All right. So now that we've labeled our two graphs, let's start by finding the area of R. Okay. So the equation to find the area of R is top minus bottom. Okay. So it's the integral from a to b of top minus bottom dx. Okay, where top is the top graph, bottom is the bottom graph. A and B are the x values of the start and end points. Okay, in this case, A, we're starting at x equals 0, and we're ending at x equals 2. So we're going from 0 to 2, and the graph on top of g of x, right? G of x is at 4 cosine. I'm going to treat this as pi over 4x, because this is kind of weird. Cosine of pi over 4x, that's the top graph, and the bottom graph is f of x. That's this polynomial, minus 2x squared minus 6x plus 4. Don't forget the parentheses, right? It's always better to have too much than too little. So we have this, and then if you evaluate this, right, we need to first start with this part, and you can do this using a u substitution. U equals pi over 4x, but it's not really super hard to do in your head. You can kind of think about it as just coefficient just kind of flips upside down, and the cosine switches to a sine, right? And then remember the integral of cosine is positive sine, so it's still positive. So we need 4 times 4 over pi. That's an ugly 4, but we'll go with it. Sine pi over 4x. Okay, so that's the first part. Again, what we just did is we know that if you integrate this, right, you can do u substitution. U equals pi over 4x, or if you want, you can just remember that when you integrate this coefficient for the x will just kind of flip upside down, and the cosine will become a positive sine, because that's the integral of cosine. Okay, so we have 4 from here, and then this guy flipped over and become 4 over pi, and then the cosine switched into a sine. That's this part, first part, and this one a lot easier, right? 2x cubed over 3. Remember, you add 1 and divide. Minus 6x squared over 2, that's minus 3x squared. So that's 4x. Okay, and then we're evaluating this whole thing from 0 to 2. Okay, so if we plug in 2 in first, we'll get 4 times 4 over pi times sine of pi over 2. Right, because pi over 4 times 2 is pi over 2, minus 2 times 8 over 3, so it's 16 over 3, minus 2 times 4, so, times 3 times 4, which is 12, plus 4 times 2, which is 8. Okay, and then if we were to plug in 0, you get sine of 0, which is 0. That whole thing would be gone. And then all of this, it will also become 0. So if you plug in 0, basically everything here becomes 0. So you just be subtracting 0. Okay, so that's not really relevant. All we need to do now is just, we know that pi over 2, sine of pi over 2 is 1. So it just becomes 16 over pi. Right? That's 16 over pi minus this whole stuff. 16 thirds minus 12 plus 8. And that should be a proper level of simplification. And we can call that there for our answer. Okay, this was a 4-point question. 1 point for the integrand at the top here. 2 points for actually taking the antiderivatives, and 1 point for the correct final answer. Part B. Write, but do not evaluate, an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 4. Alright, so to do this, first I'm going to draw the horizontal line y equals 4. It's going to look something like this. Okay? That's the horizontal line y equals 4. And the next thing I'm going to do is I'm going to define this is my small radius, and this is my big radius. Alright? I'm going to call this guy capital R and call this guy lowercase r. Alright? And notice that what this is literally the distance from the horizontal line to each of the curves. Okay? So now what we do is we need to figure out an equation for little r and big R. Okay? So little r, notice it starts at 4, and it goes down to g of x, which is 4 cosine of pi over 4x. Right? So g of x gives me this whole distance, right? So from 0 up to here. This is g of x, right? This is the y. If you get the y value, that's how much this distance is. And then this distance totally is 4, right? But I want what's left over when you take the entire distance of 4 and you subtract out this g of x, right? R is kind of what's left over after you subtract out the big g of x section. So little r, I can say it's 4 minus this g of x, which is 4 minus 4 cosine pi over 4x. Okay? Similarly, big R, it's going to be, this whole thing is 4 again, and I'm subtracting out this f of x section. Remember, this is the y value, this is the height, this distance, I'm subtracting that out. and r is what's left over. So it's 4 minus f of x. So 4 minus 2x squared minus 6x plus 4. Okay, now that we have that, all we have to do is use the equation, right? This time the equation is pi times the integral from a to b of big R squared minus little r squared dx. So literally all we have to do is plug in the numbers, okay? So we get pi times the integral from, again, we're going from 0 to 2, and this is our big R, so 4 minus 2x squared minus 6x plus 4. This whole thing is being squared, and then little r squared is going to be 4 minus 4 cosine of pi over 4x. Can squeeze it in there. Ooh, nothing squared. And then dx. There you go. So there you go. That's our final answer. Right? We just plugged in everything into our equation, and that's what we got. Okay. Remember, it's not telling us to evaluate it. It's just asking us to write the integral that we would need to evaluate. So that's it. We're done with that. This was the 3-point question. 2 points for the integrand, and 1 point for the limits and the constant. That is the pi. Part C. The region R is the base of a solid. If for this solid, each cross-section perpendicular to the x-axis is a square, write but do not evaluate an integral expression that gives the volume of the solid. Cool. Okay, so how do we do this? Well, we have this region is the base of a solid. When taking cross-sections perpendicular to the x-axis, so the x-axis is going this way, perpendicular to the x-axis is this way, vertical, right? And the first thing we need to do is find an equation for this pink distance, okay? And so we're going to do a similar strategy to what we did before. So this distance here, this is g of x, right? So from 0 to g of x, that distance is g of x, right? But I want that distance, but I also want to subtract out f of x, right? So it's this entire g of x minus f of x, all right? So what I have to do is I have to say that if I call this distance, I guess we can call it like s for the side of a square. We'll say s equals g of x minus f of x, right? Because g of x minus f of x, that gives you what is left over of g of x once you take away this section of f of x underneath. Okay, so that's the side, and then each cross section is a square. So this basically is the side of a square, right? Forgive my art skills, but that's a square, and then you have another square here, and you have all these squares, and then you need to add up all these squares, right? So since we know the side of a square is g of x minus f of x, we can figure out the area of a square, right? Because it's s times s, it's s squared. That's the area of the square. So the area of a square is s squared is g of x minus f of x whole squared. Now we're going to do the final step. So to take this square, right, in order to integrate it from the beginning to the end. So it's going to add up all of the squares across this whole region and give us the total volume of that 3D shape. So we have to integrate this from 0 to 2, g of x minus f of x squared. Okay, now I'll just fill in the actual numbers. G of x is 4 cosine pi over 4x. And then f of x is a polynomial. Like that, okay? Now I just take this, okay, square it, and that's it, alright? That was the entire problem, and this was a 2-point problem, 1 point for the integrand and 1 point for the limits. That concludes question number 5. Consider the differential equation dy dx equals e to the y times 3x squared minus 6x, y equals f of x is a solution that passes through 1, 0. Write an equation for the line tangent to the graph at the point 1, 0, and use that tangent line to approximate f of 1.2. Okay, so whenever you have these kind of tangent line questions, you always got to write down 2 things. Point and slope. Okay, so actually being nice, and they're giving us the point, it's 1, 0. And the slope, remember, the slope is the derivative at that point, so we need to find the derivative at the point 1, 0. Okay, what is this equal to? Well, we have the derivative, and we have the point, we just have to plug in 1, 0 into the derivative. So we have e to the 0, remember y is 0 in this case, times 3 times 1 squared minus 3 times 1, or sorry, minus 6 times 1. 6 times 1. Okay, and e to the 0 is 1. 3 times 1 is 1, minus 6 is that. And then 1 times 3 minus 6, that's equal to negative 3. Okay, so our slope is negative 3. And so putting the point and the slope together, we have y minus 0, so just y, equals negative 3, which is the slope, times x minus x1, which is 1. Okay, so there we go. That's our equation for the tangent line, for the line tangent to the graph of f at the point 1, 0. Now we need to use this to approximate f of 1.2. Okay, that's literally just going to be plugging 1.2 into here. So negative 3 times 1.2 minus 1, which is negative 3 times 0.2, which is negative 0.6. Okay, that's it. This was a 3-point question. 1 point for successfully finding the derivative to the graph at 1, 0. The 2nd point for successfully writing the tangent line. And the 3rd point for successfully approximating f of 1.2. Part B. Find y equals f of x, the particular solution to the differential equation that passes through 1, 0. Now you should always be jumping for joy if you see these questions, like I always say, because these are the richest source of points in the entire exam. There's it's the best ratio of points to effort. Okay, most points for the least effort. So to solve this differential equation, the first thing we're going to do is we're going to bring the y's to one side and the x's to the other side. Okay, so we'll start with the y's. We'll take this y and bring it to the left, so we'll have 1 over e to the y dy, and we'll take this dx and bring it to the right, equals 3x squared minus 6x dx. Now we have only y's and only x's, so we can go ahead and integrate. Okay, so I'm going to focus on this integral here for a bit. The integral of 1 over e to the y dy. Remember, I can bring this exponent, or I can bring this part here to the top, and I'll get e to the negative y, because when you bring this to the top, the exponent switches signs. So it's e to the negative y dy. And then if I integrate, you could technically do u substitution with u equals negative y, but that's kind of overkill here, because it's just going to be e to the negative y over negative 1, right? It's just going to be the e to the whatever is here divided by whatever coefficient you have. Okay, so e to the negative y over negative 1, which is just negative e to the negative y. If you did a u substitution, you would get the same answer, but it would just take a lot longer, that's all. Okay, so that's this part. And then this integral is a lot easier. It's just, you add 1, divide. So this would be x cubed minus 3x squared, right? You add 1 to get 3, and you divide by 3. And you add 1 to get 2, and you divide by 2. So you get 3x squared and x cubed. Okay? So now combining these all together, we have negative e to the negative y equals x cubed minus 3x squared. And then we also have to include a plus c, because this is an indefinite integral. Okay? Which will only include the plus c once for these kind of differential equation problems. Now this is just going to be a big thing of solving for c. Okay? Or sorry, not solving for c, solving for y. Okay? So the first thing we'll do is we'll get rid of this negative sign. We'll say e to the negative y equals negative, it's supposed to be x cubed, my bad. Negative x cubed plus 3x squared plus c. Again, this plus c can kind of like absorb stuff that's coming into it. If you multiply, it'll absorb it. If you switch the sign, it'll just absorb it. It'll change values, but the c is just going to stay as a c. Okay, so we have this. Now I can go ahead and take the natural log to get rid of the e. So if I take natural log of both sides, I'll get negative y equals the natural log of negative x cubed plus 3x squared plus c. Okay, and I will bring the negative over, and I'll get y equals negative natural log of negative x cubed plus 3x squared plus c. Okay, so the final step here is we need to figure out what plus c is. And to do that, we're going to use that initial condition from earlier. Okay, so remember, we had the initial condition that that was 1, 0, right? up here, pass it through 1, 0. So we're going to use that to solve this problem. Alright, so we'll plug in 1 for x and 0 for y. So we'll get 0 equals, I'll do it white. 0, still on eraser mode, sorry. 0, there we go, a couple tries. Negative equals negative natural log of 1. So we'll get negative 1 plus 3 plus c. Okay? And I can just kind of get rid of the 0 because I can get rid of the negative because it's equal to 0. So 0 equals the natural log of negative 1 plus 3 is 2, 2 plus c. Right? Now remember, we know that the natural log of 1 equals 0, right? So because the natural log of 2 plus c equals 0, and the natural log of 1 equals 0, I don't know what that is. I can say that 2 plus c must equal 1. So c equals negative 1. Okay? So I'll take negative 1, and I'll plug it back into my original equation for y. So I'll get y equals negative natural log of negative x cubed plus 3x squared. And for plus c, I'll put minus 1. Okay? And that is it. That is the equation y equals f of x. Okay? I hope you found that this video helpful. Oh, points. My bad. Sorry, I forgot. Like I said, these questions are super rich in points. This one in particular is worth 6 points. 1 point for separating the variables, 2 points for successfully taking the integrals, 1 point for including the plus c, 1 point for using the initial condition, and 1 point for the final answer. Okay, making up 6 points in total. And now I can get into my spiel. I hope you found this video helpful. Apparently my friends told me they're supposed to say like and subscribe or something. Probably that's good. So like and subscribe, I guess. And hopefully this helped you, and I'll see you next time. Goodbye.